Sir, shall we start?
Yes, I am ready. I am ready.
Then shall we start? Okay, sir. Then we will start, sir.
Okay,
Okay, sir. So good. Yes, sir.
You are going to introduce me yourself or what?
No. I am introduce you, sir.
Okay, good.
Okay, sir. So good afternoon, everyone. I am Rajguru Kamble, Assistant Professor at Department of Civil Engineering, Dr. Daulatrao Ahir College of Engineering, Karad. It is my privilege and honor to introduce our respected resource person for the 8th session of this AICTE Atal Faculty Development Program, Engineer Sambhaji Manesar, a senior civil engineer with a vast experience in road and infrastructure development. Sir has a strong educational background in civil engineering. He completed his bachelor's degree in civil engineering and master's degree in construction management with the distinction. His academic excellence has played an important role in shaping his professional journey. After completing his education, Sir began his career in the public service and has gained more than 30 years of experience in planning, construction, and management of the infrastructure projects like roads, bridges, and public buildings. At present, he is working as a chief engineer at Public Work Region Nagpur, where he is responsible for guiding and supervising a major road and infrastructure works. Earlier, he serves as the Secretary of the Maharashtra Rural Road Development Agency and the Chief Engineer of the Pradhan Mantri Gram Sadak Yojana, commonly known as PMGSY. In these roles, he played a key role in improving rural road connectivity across the Maharashtra. Manesar also works as a superintending engineer in Satara and Kolhapur regions, where he handled large road and bridge projects and ensure good quality and safety standards. During 2019-20 floods in the Sangli and Kolhapur region, he led an important flood relief and repair works, including checking and restoring more than 300 damaged bridges, which helped restore road connectivity quickly. During the COVID-19 pandemic, he showed a strong leadership by managing emergency medical facilities, including the oxygen plants and hospital infrastructure to support the public health needs. He has a rich experience in disaster-prone and climate-sensitive areas and has worked on ADB-funded rural road projects where he promoted a climate-resilient design and road safety practices, construction of the low-volume roads, execution of full depth reclamation work, and construction of lethal arch bridges. In addition to the field work, Sir has also served as a lecturer at Government College of Engineering Karad and Government Polytechnic Dhule, and sharing his knowledge to young engineering students. So today, the topic of this session is integrating disaster risk reduction strategies in the road development is highly linked to the Manesar's vast practical experience in handling the road projects in disaster-affected regions. We are confident that his session will provide clear ideas, real-life examples, and useful guidance for integrating the disaster risk reduction in road development projects. Now, I respectfully hand over this session to Manesar and request him to kindly start the session. Thank you, sir.
Thank you. Good afternoon, all. As rightly introduced by Professor Kamble sir, my today's topic is on integrating disaster risk reduction in road development. As you all aware that why this need of disaster risk reduction is being in front of us. The main culprit, the main cause behind this is the climate change. And you are aware that why this climate change year by year is occurring and what is the main cause for this. As we know that post-industrialization until date, the average temperature rise of the earth is around 1.5 degree. And because of that, so many things have been happening, like melting of glaciers, then raising of ocean water, then thermal waves, heat waves, and so on. And it is because the rise of GHG gases because of industrialization, and the main rise in GHG is occurring. The main cause is electricity development, and second is the infrastructure development. The second reason, 16% of the CO2 emission, it occurs because of infrastructure development, that is various transportation system. So as I am being in road sector, road and bridge sector, infrastructure development, it is my duty to try to reduce this CO2 emission, and of course to help to reduce the disaster risk. And that's why, probably looking to my experience, the college has invited me for this auspicious presentation in front of you. आगे चलो. Before going to this theoretical part, I will let you know. See, we all know that the Paris Accord has been held in the year 2016 by 195 countries in Paris. And for our country, it was decided that by 2035, the 50% of GDP, total GDP emission of CO2 will be reduced by 2035, and net zero will be done by 2070. So that's why from all sides, all corners of the country, we are taking efforts to reduce the GHG gases, to go for the construction, infrastructure construction, so that there will be a minimal emission of CO2 or GHG gases. And our effort is to use the reuse, recycle, so that it will help to the sustainable development. So in our today's presentation, I will specifically press on the sustainable development and climate change. Friends, during introduction, it was mentioned that I have worked during the floods. It is occurred at Sangli and Kolhapur district in 2019 and 2021. So taking that experience of 2019 and 2021, we have worked so many things in our PWD, and continuously we are working on the climate mitigation, climate disaster adaptation technologies, and so on. So during my lecture, whenever possible, I will give some examples what we are doing. Earlier, before coming to the Public Works Department, I was Chief Engineer for Pradhan Mantri Gram Sadak Yojana. And parallelly, our state government of Maharashtra was also running Mukhya Mantri Gram Sadak Yojana. So during my 4 years tenure at PMGSY, government of Maharashtra, we have constructed around 37,000 kilometers of the roads and around 1,200 bridges, long bridges. So in those constructions, we have gone for the new technologies, innovative technologies, so that we can achieve the sustainable development, as well as we'll try to reduce life cycle emission of the carbon. And what technologies we have used, I will just enumerate. In 2022, we have published a document on green technology, where the Government of India, Minister of Rural Development, they have forcefully introduced that document, and in that document, it was compulsory for us to use the green technology like recycling, use of waste material, then use of coal technology, and so on. So, taking that benefit from that document, so in our earlier works, in so many projects, we have gone for the FDR, full depth recycling, then use of fly ash, then use of coal technology, and so on. Now, we'll go to my presentation, and whenever possible, what sort of work we did in past and today we are also doing, we'll enumerate. You know that this definition, what is the disaster risk reduction and components of disaster risk reduction. Of course, it is a mitigation, preparedness, response, and recovery. Next. So this DRR, how it affects for roads, you know that for economic growth, roads are necessary. It is for national connectivity, defense movement, emergency response, and trade and logistic. But roads are vulnerable to hydrological and geological climate hazards. Now we know that across the Maharashtra, every year, even in this current monsoon also, at so many places, the floods and washing of roads has been occurred. Especially this time, it has occurred in the drought area like Marathwada and Solapur, my own district, which is a drought district. Still, we have suffered almost 1 month from these floods and its effects. Then landslides, you know that landslides block highways. So I will especially mention here, during the floods of 2019 and 21 at Sangli and Kolhapur district, landslide was the main cause which have blocked so many national highways and state highways. Then earthquakes damages bridges that you know, cyclones, heat waves. Now I am working in Nagpur where there is an extreme heat, and because of this climate change, the frequency of heat waves have increased. Next. Natural hazards or disaster, you know that cyclones, floods, earthquakes, tsunamis, landslides, no avalanches. During my last 30 years, I have coped with floods and its cloudburst and urban blast. We have taken number of measures in my day-to-day work in our PWD also. Of course, there are IRC codes which are modified accordingly. Then we have worked with landslides also. Then man-made disaster, industrial accidents, road accidents, other emergencies, pandemics. Next. Now, why DRR is needed? In my initially only I told you that because of the climate change, so many things are happening, floods, heat waves, and all. And because of that, so many things, landslides, washing of bridges, washing of roads, etc. is being happened. And to cope up with those things, we need to go for the disaster risk reduction. The 40% disaster is being happening because of the flood prone terrain. Then 60% earthquake, 70% of road affected by heavy monsoon, and large sections in landslide prone Himalayas. Such landslides are happening at Kolhapur and Sangli, every year it is happening. So roads suffer frequent failures, waterlogging, road closures in hills, embankment erosion, river overflow cutting roads. Then what is the DRR benefits then? So safer roads, lower O&M costs, reduce reconstruction post-disaster, minimizes traffic disruption, ensures emergency mobility, complies with, of course, what we are doing, measures we are taking, this complies with the MRTH, NHI, IRC requirements and their codes. Next. Ministry of MRTH, Ministry of Road Transport and Highways, they have circulated so many pro forma circulars or sections. Disaster Management Plan for Road and Highway Sector, Section 300, earthwork. How earthwork should be constructed, how its slopes should be protected, how it is to be compacted. Then clause 305, how the embankment should be designed and protected. Then how drainage requirements are to be fulfilled. In section 2500, retaining wall and slope safety structures. And in 2022 hazard risk circular, mandatory risk assessment procedure is being led. Then NHI has given some guidelines for preparation of DPR, detailed project reports. So while preparation of the DPR, we should think of hydrology and flood modeling, landslide assessment, road safety audits, climate vulnerability evaluation, stormwater design. Next. Then Indian policy and code. There are so many codes which have been referred here. Next. Then stages of disaster risk reduction. What should be the stages? As we all are engineers, we know that whatever we have to achieve, what is our target, that we have to start from our planning stage only. So if you want to reduce the disaster, especially in case of roads and bridges, I am talking about. So we have to plan right from the DPR preparation only. So at planning stage, avoid hazards, select safe alignment. For greenfield roads, we have that alternative to change the alignment. But for the brownfield road, on the existing roads or existing alignment, we don't have that alternative. Of course, locally we can change the alignment. Then during DPR stage, conduct detailed studies and modeling. Here in our PWD or in our PMGSY, we used to have a transect walk during DPR preparation. So what is the transect walk? We let our consultant, our engineers and surrounding people walk around the road which we are going to develop. So that so many things, environment, social and physical and technical things can be assessed on the sites and those can be incorporated in the DPR. Then during design stage, apply engineering-based mitigation. So you have to go for the traffic measurement, then design of the crust and so on. And looking to the climatic condition where the road is, depending on that, we have to design the road and bridges. Then during construction also, we have to think of implement safe construction practices. Then, of course, there is a defect liability period, or which you call as a maintenance stage. And these all aspects you have to monitor during the maintenance stage also. Next. Then planning stage. What activities we do? Flood plains, river meandering zones. So we have to think about which plain it is. what is the rainfall, then river, if we are going to construct the bridge, then what type of river it is, whether it is meandering or the area where I am working. There are so many cases, incidences where after construction of bridges, the river is getting meandering. Then landslide, whether the area lies in the landslide zone, seismic zones, cyclone prone regions, erosion prone areas or what. Then alignment selection. Avoid alignment selection of the road in the active landslide slopes, high flood water level areas, unstable geology, extremely steep terrain. Then climate assessment, future rainfall projection. So during your planning of the road or construction of the road, so you have to think about the future rainfall projections also, temperature variations, snowfall, frost areas, etc. Next. So here at DPR stage, what sort of things we should consider I have mentioned. In one, hydrological analysis. So what is hydrological analysis? If you are going to design a bridge, then of course we take a peak discharge of that. Then accordingly we define the HFL, high flood level. Then what should be the clear waterway of the bridge? Then during calculation of the HFL, whether we should think of 50 years data or 100 years recurrence of flood recurrence. So that we have to decide. Then geotechnical investigations, of course, soil classification, then bearing capacity, slope stability, liquefaction check, and landslide analysis, factor of safety, benching requirement, reinforcement or retaining type, DPR mitigation planning, design of retaining walls, drainage channels, pavement type stability, erosion control measures, and so on. Next. Then design stage. Design stage, what we design for the road, embankment, pavement, cross drainage works, and slope protection. So in the embankment, our top level of embankment should be designed such that it should be at higher than 1 meter from the HFL. So it should be HFL plus 1 meter. So there should be a freeboard of 1 meter. Then use of suitable soil. The soil having CBR more than 8% should be used. Then slopes. For the slope, its slope should be 2 horizontals to 1 vertical or as per stability requirement. Then for pavement, the pavement should be temperature-based selection of bitumen grade. Then rut resistance mix design, drainage sensitivity design in high rainfall zones. Of course, for openings, cross drainage culverts or bridges, adequate waterway should flow through the roads, score depth calculation, debris load estimation, and so on. And for slope protection, we'll go for the soil nailing, geosynthetics, grass turfing, and gabion walls. Next. And during construction stage, proper compaction for embankment, it should be 95 to 98% proctor density. Then it should be constructed with layer of 15 centimeter to 20 centimeter. Then drainage during construction, avoiding blockage of natural streams, temporary two walls or short pit, control blasting in hills, correct retaining wall backfilling, grain size control for filter, safe equipment movement on hill stove. Next. The maintenance stage, there are short-term maintenance, long-term monitoring, and modern monitoring tools. In short-term maintenance, there are 15 to 16 activities we have to do. Cleaning of side drains, removing silt from culverts, crack sealing, pothole repairs. And in long-term maintaining, slope movement tracking, rut depth measurement, pavement roughness, bridge settlement or till, score monitoring after monsoons. Then for modern monitoring tools, there are drones, LIDAR, 3D scanning, GPS-based deformation sensors, smart bridges monitoring system, and so on. Next. Then our DPR should accompany all the hazards which can happen in that alignment. So we should think of all these things in our DPR. Our DPR should be reflection of all the things, whatever we have saw so far. That is landslide, slope failure at DPR. Hazard causes, you know, that weak rocks, excess poor water pressure, side cutting in hills, and then seepage water. One example I will put in before you. In 2021, you must be knowing that Panala Port, the approach road to the Panala Port, it was totally subsided. It was subsided because its foundation protection was excavated by the local people, and that's why it has become unstable, and there was a serious landslide, and that road was subsided. Of course, I have a PPT of that. I will show if time permits. Then structural measures you have to take. And you see, in the disaster reduction, the drainage measure is very important. So that's why the hydrological study of the area is very important. We see that we construct roads, but there is a lack of drainage planning, systematic drainage planning. And that's why there are so many things has been happened. Outplanking of bridge approaches, isn't it? Then green engineering. Under green engineering, you have to go for the green roads, green innovation technologies like recycling, use of fly ash, and so on. So under green engineering, biostabilization, vetiver grass, Geohazard Koyna technologies, and all this. Next. In the flood risk reduction in roads, you know the causes of flood damages, that is inadequate culverts. As I rightly told, during the planning itself, you have to correctly study the hydrological details of the area. And accordingly, there should be sufficient opening. The water which is coming should easily pass through our roads. So that's why there should be an adequate number of culverts or bridge openings. If it is inadequate, so it causes to the damage. Then poor camber, low embankment levels. At some, you might be having experience that at some locations, the adjoining landfills or farms, their levels are higher than our RTLs. So in such cases, there will be always waterlogging, and the water will be on the road, and hence the traffic will be stopped for so many hours or days. Then poor side drain slope. You have constructed side drains, but if you don't have proper slope, how the water can flow then? So there should be a proper slope, at least 1 in 100. Okay. Then river migration, you have to think of the river migration also. Then coming to the mitigation measures. In the mitigation measures, as I told you already, that the embankment level should be proper. It should be always 1 meter higher than the HFL. Then coming to the camber is always for BT road, it is 3%, and for rigid roads, concrete roads, it is 2.5%. Cross drainage culverts design using IRC SP 13, retained period for 50 to 100 years. Then flood protection, guide bunds, riprap, launching of aprons, should be there. And of course, the drainage, line trapezoidal drains as per requirement, then median drains, shoulder drains should be there, and its network should be proper. So there should be a sufficient slope. Water coming should flow and it should ultimately reach to the river through the streams. Next. Then seismic risk reduction, seismic zone identification. In our country, there is a proper identification of zones. So accordingly, you have to cater the seismic zone also, and that should be incorporated in our design. Then pre-seismic design, mitigation measures. For seismic risk reduction, what should be the mitigation measures? There should be use of elastomeric bearings, seismic arresters, shear keels, flexible foundation, soil liquefaction analysis, seismic separation gaps, etc. Next. This cyclone and that don't appear in my scope, so I will skip it. Next. Extreme temperature impacts. There are regions. Now the region where I am working is called as Nagpur region. Here it is called as a hot region. There is a extreme temperature during the summer. So their problem is that bitumen bleeding, rutting, texture loss, oxidation of bitumen. Then what is the solution? So you should go for the PMB or CRMB or anti-rutting mixtures or stone mastic asphalt or of course the government of Maharashtra, we are going for the arboriculture since long. There are sufficient trees around along the road, shade plantation. And cold region, we don't face the cold region problems here, so I will skip it. Next. Now, for embankment stability measures, already I have explained that the compaction should be 95 to 98%. Then the slope of embankment should be 2 horizontal is to 1 vertical or flatter. Then there should be benching of layers. Then what the material we are using should have a CBR of more than 8%, at least for the top 500 mm thickness. Use of borosile with less plasticity. Then for erosion control, in waterlogged area, there you should take the erosion control measure also. So what we should do, we'll go for the stone pitching of 230 mm to 350 mm thick, or riprap for riverside embankments, geotextile filter layers, or turfing or grass for side slopes, 2 wall for base protection. Next. And for road drainage, there are type of drainage. One is the surface drainage, then subsurface drainage, cross drainage works, and medians and shoulder drainage. So under surface drainage, you know that there should be a sufficient camber. It should be a 3% for bitumen road for rapid turn of the water. Then side drains slope should be at least 0.3 to 1%. And there should be sufficient catch water drains in hills. For subsurface drainage, there are French drains, horizontal drains, blind drains. And cross drainage works, there should be an adequate number of box culverts or pipe culverts or minor bridges as per the hydrology, as per the discharge of the runoff. Then for the medians and shoulder drainage, perforated pipes, longitudinal drains or open line drains should be constructed. The more important is that 85% of the road failures, they occur due to the poor drainage. Next. For bridge safety and disaster resilience, hydrological measure is an important thing. accordingly, the waterway is being decided. Then there should be a proper study of core depth estimation. Then flood discharge studies, seismic measures. You should have proper bearings, seismic arresters, reinforced pipe, pier caps. What the foundation measures? For foundation measure, depending on the soil characteristics, you should go for the pile foundation or caisson foundation, well foundation or open foundation, and so on. And coming to the protection work, there should be a guide bunds, launching aprons, or river retaining works. Next. This climate change adaptation, so we don't have an option but to adapt with the climate change. So for this, during the design stage only, we should properly consider the 20 to 30% increase in design rainfall, increase in culvert waterway. Here, I will just mention one example. Yesterday only, I had visited a bridge whose length is 550 meters on Andhadi River in Chandrapur district. They have completed the construction of bridge in 2024. Before 2024, and immediately construction in 2024 monsoon, the flood has occurred. And the HFL of that flood was just 40 centimeters below the soffit. That bridge was designed as a high-level bridge. You know that in high-level bridge, we give, after HFL, we give 1.2 meter of freeboard. And on that, a flux of 0.4 to 0.5 meters. So almost it is 1.7 meter on HFL. But here, though it was decided high-level bridge, but during last monsoon, the highest flood level was 0.4 meter below soffit. So it means that the flood level of this year was 1.2 meter higher than the design flood level. Yesterday only I visited this site and we have gone for so many things. Now we decided that instead of high-level bridge, we will make this bridge as a submersible one. So we have taken so many measures. I will tell you later. Then materials, geosynthetics. There are so many geosynthetic materials available in the market. Fiber reinforced concrete. We can go for the rubberized bitumen also. Slope protection, then fire jute textile with vegetation, RE wall for flexibility. In coastal roads, salt resistant concrete, there's salt resistant cement is available. So especially in the coastal region, salt resistant cement should be used. And of course, our courts have given more cover for the concrete construction. Then high wind design, seawall protections, and so on. Next. Technology and monitoring, advanced methods. So you should plan or survey those areas by the advanced method like drone photogrammetry, LiDAR-based terrain scanning, ground penetrating radar, smart sensor for bridges, AI-based traffic monitoring, and digital monitoring, BIM-based building infrastructure monitoring based asset management, IoT sensors for slopes, remote deformation measures. Next. So there are so many case studies we have been listed over here. Next. वो मेरा presentation दे दो. वो ये these are the case studies from outside the state, but I will put one case study which we have dealt with when I was AC Kolhapur.
डाउनलोड किया तो पीडीएफ था
नहीं पीपीटी है एक इसका वीडियो है, वीडियो दिखाओ उसका, नहीं तो
वीडियो दिया है। पीडीएफ नाही आता दिला तुला मगाशी मी. 5 मिनिट का वीडियो है. पन्हाळा प्रेजेंटेशन है 23 स्लाइड का. कमाल कर सकते हैं.
हो जाओ.
डायरेक्ट स्क्रीन शेयर कर.
फॉरवर्ड. थोडं पुढे जाऊ. मागे मागे थोडं मागे. ठीक आहे. आगे ले लो. पॉज कर. पॉज. आता ते त्याच्यानंतर काम केल्यानंतर. ठीक आहे, बंद कर. This was the one case study which occurred, a landslide of a road which was approaching to the Panala Fort of Kolhapur district has occurred in 2021, and we have taken the measures as you saw there. Oh, the second or third now दिखाओ. So the technology methodology used for this was the Cirascape technique. And the design consultant was for this is a tensor geosynthetic. Okay, बंद कर. In our earlier department and in PWD, looking to this climate change, to mitigate the climate change, to adapt the climate change. So now we are going for the, whenever possible, we are going for the full depth recycling. Then, as far as possible, in the embankment, wherever possible, we are using the fly ash. Then, for concreting, we are going for the blended concrete. Instead of OPC cement, we are using PPC. Then, we are properly planning, we are taking care of planning of the drainage. In waterlogged areas, we have a IRC we are taking measures through the respective IRC. Then we are in some areas we are going for the cold mix technology also. So like this, we are thinking the sustainable development at one side, and we are trying to reduce the carbon emission so as to meet the requirement of Paris Agreement. So our efforts are towards reducing the CO2 emission and helping the sustainable development. So this was my presentation. So those who have any difficulty, please be free to ask me. If anybody want to ask something, please be free to ask.
Hello, Mane.
Yes.
I am Dr. Agarwal. I was there in Karad up to 99.
Yes, sir. Yes, sir. Yes, sir. Nice to see you, sir.
It's a long time to see you after more than 30 years.
Yes, sir. Yes, sir.
And very nice, presentations. A lot of things you have covered. You
Yes,
have
sir.
worked in this area, I think, almost half of your life. Definitely, say, a lot of contents or say case study what you are showing about this Panala.
Yes,
One
sir.
query about this Panala, whatever I have seen your this video one. Now this water is coming from such a height. Is there any possibility of energy generations by putting maybe some turbine or something?
Okay, sir. So we didn't think it, but it may possible, sir.
Okay. Okay, good to see you.
Yes, sir. Thank you, sir. Thank you, sir.
Thank you.
Same here.
Yeah, thank you.
Anybody else?
Participants, any other doubt from your side?
See, there was a question, why you preferred PPC instead of OPC? So as you know that in PPC, we use at least 25 to 30% of fly ash. Okay. And fly ash is a waste, and it is abundantly available in Maharashtra, especially in Nagpur region. If you replace the 30% of cement by fly ash, what will happen? The energy required to 30% of cement will be reduced. And ultimately, to prepare that much energy, we require CO2 emission. So that much CO2 emission will be reduced. So that is the one thing. First thing is the sustainable development, means we are using wastage, and secondly, we are reducing the CO2 emission. So this is the purpose. And of course, it is giving at par strength with the OPC. Next, I think there is no more question. So is it right time to stop here, Manali?
Okay, sir. So shall we conclude this session?
No, from my side, it is over.
Okay. So any participant wants to give a live feedback to this session or any query? Okay, sir, we will conclude over here. On the behalf of organizing committee of this AICTE Atal Faculty Development Program, I, Rajguru Kamble, would like to express our sincere gratitude to Engineer Sambhaji Mane sir for sharing his valuable knowledge regarding the DPR process, materials which are used for the construction of roads and its safety, with the rich professional experience and practical insights with us. Sir, your real life examples, field experiences, and the clear explanations provides us a deep learning all the participants and help them to understand the practical aspects of the road infrastructure planning and the development. Your guidance was highly enriching and very much appreciated. I would like to extend my sincere thanks to all the participants for their active presence and keen interest and enthusiastic participation throughout this session. Your engagement and interaction contributed significantly to overall success of this session. Once again, we will express our heartfelt thanks to Engineer Sambhaji Mane sir for his valuable time and the contribution. And thank you to all the participants for joining this session and making this session successful. Thank you so much, everyone.
Thank you. Thank you so much.
Thank you, sir.
Thank you.